Okay, so today we're going to be talking about exponential growth and decay, and the formula we were given is P of t equals P naught e to the kt, and then of that we know that P naught, which is right here, is equal to the initial amount, and K is our growth constant, and then of that what we get is P of t, and that is the resulting amount and also the function in terms of time. So then also this is for growth. So then if you have any decay, it is the exact same equation pretty much, except instead you have a negative k to the t, kt. Oh, sorry, but so yeah, so that would be for decay, and then the next thing we're dealing with is double time and half-life. And for those, you start off with the same equation, which is P equals P naught times e to the kt. And then you're essentially trying to just rearrange those for a t. And then in the case of double time, you're going to have, so you actually start off with moving the p naught over, which will turn into p over p naught equals e to the kt. And then in that case, since it's double, you're going to have double the amount of p on the top, which will leave you with 2 times p over p naught equals p naughts. And then that equals e to the kt. So then now these p naughts will cancel, and then you're going to have 2 to the 2 equals e to the kt. So then now, in order to get rid of that e, we can ln both sides. So we'll have on 2 equals kt. Then this can now be rearranged so that we will have just t. So then t is going to equal ln 2 over k. So that's what it is for double time. And then you could think of it as for half-life. You're going to have the same start here, but instead you're going to have half p naught over p naught, and that equals e to the kt. So then now, again, p naughts are cancel, and you're going to have half equals e to the kt, and we're then going to end up with ln half equals kt. And then from there, you could think of it as ln 2 to the negative 1 equals kt. And then from there, this can all be rearranged, and it's going to end up equaling actually the exact same as the double time equation, which is t equals ln 2 over k. So then it actually works out that for both of these, our equations are the exact same. Okay, so we're going to do a little example here. So we're given that P of t equals 2000 e to the 1.3t. So our growth constant is 1.3, and we initially have 2000, and we're trying to figure out when P of t equals 10,000, what our time would be. So then now, if we just put in 10,000 into the equation, we're going to get that 10,000 equals 2000 e to the 1.3t, and then we could just divide this over to the 10,000. So we're going to equal 5 equals e to the 1.3t, which then you could ln both sides. So you get ln 5 equals 1.3t, and then just divide the other side by 1.3. So t equals ln 5 over 1.3, and then that will give us that t is equal to 1.24 hours. Okay.